Good morning, my YouTube viewers. It is Crystal here. I'm here to give you a code review. Unfortunately, this is a code review with the Kaggle community competition where you have to predict forest fires. And basically what happened was the people who did the competition did not allow us to make our notebooks public. And because they did not allow us to make our notebooks public, I had to wait until after the competition had ended in order to do a code review and a blog post on this competition question. So unfortunately, I won't be able to give you a link to the Jupyter notebook because it's private. And I waited until like yesterday was the end of the competition, and then they were supposed to allow people to make their notebooks public at the end of the competition, which they didn't do. So I won't be able to give you a link. So you just have to go over the code with me, and that's all you'll be able to do. But you see, I got on my private score, I got 100%, and on my public score, I got 94.5%, which I was quite happy about. So, so that was a good score. And then the problem statement is this competition is to predict forest fires. So that's what we were doing. We were predicting forest fires. So the first thing that you need to do is you need to open your Jupyter notebook or create a Jupyter notebook, and which is what I did. And then when you created your Jupyter notebook, what you have to do is you have to import the libraries that you're going to use. And so I imported NumPy as MP, that's your numerical computations. I imported Pandas as PD, that's your panel data and data processing. Imported OS, which goes into the operating system. Imported XGB, which is XGB because that's not part of the sklearn library, so that had to be imported. Imported matplotlib.pyplot.splt. That's your graphics. It enables you to visualize the data. And then I imported Seaborn, which is also graphics, but it has statistics in it as well. And after I imported the libraries, I used OS to find the files that were going to be used. And the files that were going to be used, they gave us a train set and a test set, and we had to make our own submission set. They didn't give us a sample submission to use. So then we have to read the files, and so we use Pandas to read the files. So in Pandas read the files and it converted it to a data frame. So we have the train data frame and the test data frame. So this is your train data frame, and it has all of this information: day, month, year. The year was in 2012. Temperature, and then I know about rain, and I don't know what the rest of these columns are because I didn't see it in the competition question. And then we have classes. Classes is 1 or 0. So I'm assuming 1 is a forest fire and 0 isn't a forest fire. So I wanted to see what columns we had in the train set, so you can see all the columns that we had. I wanted to see the train info. You can see all of the info is a numeric except for DC, which is an object. So I wanted to see all of the number of unique values for each column, so you could see the number of unique values for each column. Wanted to see if we had any null values. In classes, we had 1 null value. So what we had to do was we had to drop all the null values. So we dropped that 1 null value, especially if it was classes and a null value. It wasn't going to be meaningful to the prediction anyway. So we checked for null values again, and we don't have any null values. So we checked for test. The format of test is similar to the format of train, except for the fact that it doesn't have a classes column. check our test columns. The test columns has the same amount of columns except for it doesn't have a classes. We check for null values. There's no null values, which is good because if there's not any null values, it means that you don't have to impute anything. So that's good. We analyzed the train. You see we had more ones than we had zeros. Okay. We combine, and we could have, another thing that we could have done, which I didn't do here, is we could have done a value counts, and then if we did a value counts, then that would ascertain that there were more ones than there were zeros, but I didn't do a value counts, which I could have done it. We combine our train and our test set, so the target equals train classes, ID equals test ID, because ID is extra. There was an ID in train that wasn't in test. There was an ID in test that wasn't in train. So we do train dot combine comb equals train dot drop classes access equals 1 dot append test dot ID access equals 1. And then we've got our comb, which is the combination of the train and the test with the two columns dropped. So we wanted to see what unique values we had in the combi. So you can see the number of unique values in combi. You can see year, there's only one unique value. So we check for null values. There's not any null values in combi. So what we're going to do is we're going to drop year, because in year there's only one unique value, so it's not going to add anything meaningful to the prediction. So we just drop the year because everything was in 2012. We check info combi, so everything is in numeric except for DC, which is an object. So we take DC, combi DC, and we convert it to a float. And now we're going to analyze combi. We're going to analyze the day with rain, so you can see the day of the month and how much rain you had on the day of the month. And so on the 31st you had more rain than any other time, and you also had outliers. And then now what we want to do is we want to check the day of the month and its temperature. And so you can see, you can have a look at the temperature and see which day of the month had the highest temperatures. Now we're going to check the month and the temperature. So you can see that the highest temperature was in August. So that was interesting. And we want to check the month and the rain. And the highest rain looked like it was in September, but we had quite a few outliers. So that was a good analysis. Oh, and by the way, I didn't win a medal or anything for this competition question, even though I got 100% on private. So now we do a heat map, and so you can see the heat map. And on the heat map, you can see that we had quite a few columns that had a high correlation. So here, what we're going to do is you can check your correlation with your columns here as well. So what we've done is we have inserted code to remove columns that have a correlation of greater than 95%. So we dropped one column when we did that. I think it dropped one column. Okay. I think it dropped one column when it did that. Now we check for null values. We don't have any null values. We normalize the data, and what you do there is you take the data and you convert it to a value between 0 and 1. So every cell is a value between 0 and 1. And then that helps in the training, fitting, and predicting. So now what we do is we define our dependent and independent variables. So your dependent variable is your target. Your independent variables are X and X test. So X is COM-B, 0 row to the length of train, and X test is COM-B, the length of train to 0. Check for null values. We don't have any null values. And now what we do is we insert code to take the train, the X variable, and convert it to a training and validation sets. And so you had to create an extra column called target to put the Y variable in there, or the target in there. And then so train equals X dot sample. It's going to be 90% of X, random state 42, and so that's your train. It's going to be a randomly sampled 90% of that. And validation is X, but you're going to drop the train dot index. So the only thing you're going to have left is the 10%. So X train is going to be train all of the columns except for the last one. Y train is going to be train the last column. X val is going to be val all of the columns except for the last one. Y val is going to be val the last column. So we check our shapes. So you see you've got your shapes here. We've got 11 columns on the independent data. And now what we do is we select our model, and we're using XGB classifier and XGBoost. So we train the model, and then we fit it, and then we check our accuracy, which is 100%. We predict on the validation set. YPRED equals model.predict xval, and then we print our score, which is 89%. We put in a confusion matrix, and so you can see that the confusion matrix is very good. We had 6 zeros and 1 1 that should have been 0, and we have 11 ones and 1 0 that should have been a 1. We compare our actual values against our predicted values. And now we predict on our test set. Prediction equals model.predict x test. And then the prediction is going to be an integer. So prediction equals prediction.asType int. And then it's the prediction. And then we prepare our submission. Submission equals pd.dataFrame. Submission ID equals ID. Submission classes equals prediction. Submission.toCSV. Submission.csv index equals false. Submission equals pd.readCSV. Submission CSV submission. And here you can see our ID and our classes. And then I submitted that to Kaggle, and I got a 94.5% public score and a 100% private score, but I didn't even get a medal. I didn't even get a bronze medal for that. So there you go. There's our code review. And unfortunately, they wouldn't allow me to make this public, so I can't give you a link. But I do want to say that in the future, I'm working on a project at the moment. But in the future, I'm going to be studying TensorFlow. And whenever I study TensorFlow, I'm going to start doing TensorFlow code review. So that's something to look for in the future. But I won't be able to do that until I finish this project that I'm working on. Okay, so it's going to be a little while, not too long, but a little while, I'm going to start doing TensorFlow. So thank you so much for watching my video. Thank you to my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And I look forward to making more videos for you in the future.